This we are going to see about the forward kinematics and inverse kinematics, right? So in this session we are going to see the forward kinematics, inverse kinematics, and the difference, right? First I would say the meaning of kinematics. It is the study of the motion, the path, right? So in this session we are going to see about forwards and this reverse kinematics. Okay, students, shall I continue as my screen is visible? Okay, shall I continue?
Yes, sir.
Okay,
Yes, sir.
now leave this portion. So now I am going to start from this portion. So now this is a link. So now let us assume this is a robot link, right? Now this is a link one. This is another one link. It is attached with a joint. Hope you know the meaning of joint. This is a link one and this is link two. This is link one and this is link two. I have attached these two links through the joint. We have joint 1, 2, 3. Okay. Now we are going to use an end effector. This portion is our end effector portion. Or we can place a gripper or a tool portion. So this is our final portion. Okay. Now I am going to take the reference from this base. I mean this first joint. Okay, so it is our first joint. This first joint, I gave the reference point, and this is the line which is going to take for the distance of x and y. So first I will tell you the distance of x and y. It is the distance from this point to the height. It is our y portion. It is our y. Similarly, you can draw this line. It is our x portion. X portion. Okay, now you can see this, it is x. Okay, so this is the assumption I'm going to made for this robot kinematics and to derive the kinematics of the links. Okay, this is our x, this is our x distance. Okay, now I'm going to give some other terminologies. It is wait, I'll erase it. Okay, now I'm going to give this link length. This link length is L1 and L2. This is link 1 and this is link 2, and its length is L1 and L2 respectively. Okay, and we have the angle. This is the angle. It is theta 1, theta 2, and pi, right? We have this. Okay, now this is a link 1. The angle made from this horizontal line, which I did know, this is called theta 1. This is theta 1. And we have the same line. This line is a completely imaginary line. Now we are going to compare the angle with respect to the link 1 is theta 2, right? We have this line, no? This line with respect to this link 1 is called as theta 2, right? Now this link 2 with respect to the horizontal line we developed initially, no, it is called pi. Okay, so these are the three notations we are going to use for the angle purpose, right? Next is we gave some terms here. L1, L2 is the length, so the length of the links L1 and L2. Then now I'm going to draw or to find the parameters, right, for this forward kinematics and reverse kinematics. Okay, so these are the assumptions and these are the some parameters we are going to fix, and we are going to find the knowns and unknowns. We have some terms, no, right? Now if the problem, if say for example we gave a problem to you, okay, in this problem we have some parameters. It may be known or it may be unknown to you. We have this theta 1 and theta 2. These two things are known to you, means, right? This two terms is called as joint space. It is called joint space because this is our base and we are going to take it as our reference. So this is our joint space. And next is called as world space. Say what is world space? We have the end effector or a gripper, and this robot is going to contact with the external world or to communicate with the external world or to the other robots. So this portion is going to communicate. with other robots or to external world. Then why we are calling it as this world space. This is called world space. Okay, we have the distance. It is x and y. Here I gave you already the meaning of x and y. See, it's the distance of this height. It is our y, and this is so the distance of the length. It is called as x. Also this angle. Okay, this three parameters is related to world space. World space. Okay, next is we are going to give. Okay, so this coordinate system is called as absolute coordinate system of end effector. Here we are going to use it as end effector. This E denotes its end effector. Okay, now we gave the joint space, and if you're going to find, right, this x, y, and pi means, then this is called forward kinematics. You don't know the value of x and y, and you don't know the value of pi, but you know the value of theta 1 and theta 2 means, then it is called forward kinematics. Okay, but contrastingly, you know the value of x, y, and pi. You are going to find the value of theta 1 and theta 2 means, then it is called reverse kinematics. Reverse kinematics is often called as inverse kinematics. Okay, so there's a difference between forward kinematics and reverse kinematics. Okay, in both these kinematics, we are going to find the angle or the links and these things, right? So we are not going to consider the forces for this both kinematics, right? But this is a meaning of forward and reverse kinematics. Hope you can understand what I'm telling. Here, so here in this picture, so here we can show this is the difference between forward and this reverse kinematics. So in general, in theta, so in theta, if you are going to consider this theta, if it is in anti-clockwise direction, then you will consider this symbol is positive. Okay, so this is a thing you have to remember. Okay, now I'm going to continue with this same picture with a slight modification. Okay, here I'm not having the link completely, but it's a line. So here I gave a line, that's all. Okay, now I'm going to use it. Students, shall I continue? Yes, my screen is visible.
Yes, sir. Continue, sir. Visible, sir.
Okay, okay, okay. Now this is a joint. It's a joint. It is a first portion. It is a joint, and it is a link one. It is a link two. Okay. Now it is the length of the link. We know this L1, and it is the length of a link L2. Okay, very good. Now we are going to find what? Now we are going to deal with this forward kinematics. Say what is forward kinematics? We know already. This theta 1 and theta 2 is given, but we have to find this x, y, and pi, no? So we are going to find this x, y, and this pi. So we have to derive some equation for that. So it is our main objective. Okay. If you are completing this, then you can know this forward kinematics very well. Good. Now we are going to derive based on the simple trigonometric relations. We know the trigonometry, sine theta, cos theta, tan theta, these things we know, right? So based on these simple relations, you can derive the forward kinematics relations. Okay. Now x, y, it is a x, y. We know in final we have to find this x, y, and pi. Okay, x, y, and pi. So these are the term you have to find. You have to find. But you know what? Theta 1 and theta 2. Theta 1 and theta 2 is we know. This theta 1 is known, this theta 2 is known. And also this link length is known. Okay, this link length L1 and L2 is also known to you. Okay, now you have to mark this L1 here, and you can find this distance between these two portions. These two portions, no? You can find these two portions because this is theta 1. Now you can get it as it is a type of right angle triangle, right? It is a, okay, from this triangle, you can see this length is equal to L1 cos theta 1. This is L1 cos theta 1. Similarly, this length is equal to L1 sin theta 1. Okay, no issues. But we are going to consider this portion now to find what? Total. Okay, this is our total x. Here I gave this total x portion. Okay, now you can find it as L1 cos theta 1, and you have to use this distance. Here you need to find this distance. This two distance can be find by this line. Here you can see this line now. Now, if you're considering this link 2, then you can get an this second right angle triangle. So here also you can get a triangle. In this right angle triangle, you can find this total angle. It is theta 1 and theta 2, no? So it is a summation of theta 1 and theta 2. So, okay. So now in this, you can get it is cos theta 1 plus theta 2. Okay, cos theta 1 plus theta 2 is available. Okay, it is a simple trigonometric relations. Okay, here you can get the total angle. This portion is total angle. Also, you can get the height. This height is equal to, since you're having the theta here and this is your, what is the side? So here it is your opposite side. From this opposite side, no, you can get this opposite side. From this opposite side means it is related to sine theta, and here you're having the total angle. So this is sine theta 1 plus theta 2. So you can get this L2 sine theta 1 plus theta 2. So you can get this length, and this length here. Similarly, you can find this height. So it is very easy, because here you're having a theta, then you're having this sine theta, no? So you can get L1 sine theta 1. Okay. Students, do you have any doubt? Students, do you have any doubt? Hello? Any doubt? Hello?
No, sir. No doubt, sir.
Okay. Okay. Now, okay. So now we know these things. Now we are going to give the short form. I mean the shortcuts, right? Here, I'm going to give the shortcuts for cos theta 1. We will have this cos theta 1 is called as C1, and this sin theta 1 is called as S1. This cos theta 2 is called as C2. This sin theta 2 is called as S2. Similarly, cos theta 1 plus theta 2 is equal to C12. We'll call it as C12. We're not going to call it as C1 plus 2. We'll call it as C12. Okay. Next is sine theta 1 plus theta 2 is called as S12. So this is a notation we are going to use. Okay. Now, sir, my total aim is we are going to find x, y, and pi. No. Now, I'm going to view this on the second page. Wait. Yes. Okay, now I'm going to give this x and y in terms of this C1L. Okay, let's wait. This is your x. Here you can add this. This is L cos theta 1 plus L2 cos theta 1 plus theta 2. So you can add this, you can find x. Similarly, y. This y is equal to L1 sin theta 1 plus L2 sin theta 1 plus theta 2. You can get y. Then how can you find the pi? We know this pi is equal to theta 1 plus theta 2. So we found these things. We can find the relation between this theta and pi and this x and y. So you can find the length. Then you can able to find these relations. No, so this is called as forward kinematics, right? If you can able to find the length of x, y, and pi, means from the value of this C1, C12, then it is called as forward kinematics. Students, do you have any doubt in this forward kinematics? Any doubt?